Hello, in this one I wanted to show a quick example of how to do multiplexing on multiple file descriptors on Linux or most Unix systems. And for that I will pick just the most common example of having a TCP server talk to multiple clients. So here I already cooked up an example where I have a very simple TCP server, so I create a TCP socket. I just set this option which allows the TCP socket to reuse a port because otherwise it crashes when you try to bind multiple times in a row. This is just for the video. Then I bind to port 8080 on any address, and I listen for new clients. And here I have an example for like only one connection, so I accept the connection and then I receive some stuff and I send the exact same stuff back. And so right now, if we compile it and then we use netcat just to communicate with it and have a very simple client, we say hello there, and we can see that it works. But if I have a second client, like so, we can see that I can type whatever I want. It won't work because the accept is only called once. And also, I mean, this loop is only for one client. So now I'm going to show you how you can use the poll syscall to have multiple clients and talk to them, well, not in parallel, but concurrently, I guess would be the word. So yeah, let's do that. So first of all, we will need a list of clients file descriptors, and I have the variable max clients above, which will just be the maximum number of clients, and then we will just keep track of the number of clients we currently have. Next, we will have the while loop over all of that. And so basically now, what poll does is that you give it an array of file descriptors, and like poll will wait for any event on any of those file descriptors, and it will return if there is one or more events for those. And by event, I mean like you can read from it or you can write to it. In our case, or you can accept from it, these kinds of stuff, like can you interact with it. So let's just poll takes a list of this struct, which is poll fd, like so. Let's call it poll fds, like so, and will be max clients plus 1, because we will also poll on the server file descriptor, like so, and so we will put the server file descriptor as the first one, and so this will take a file descriptor fd, and then there will be an events. And so events is a mask of which events do you want to listen on. In our case, it's only poll in. There's also poll out, which is to write, and there is poll r for errors, and I think there is poll pre, I think, for like priority things, but I don't know. For now, I've only used poll in. And there is r events, which will be when, for now it's 0, but after poll has finished doing his stuff, it will set r events to non-zero, to whatever events are available on this file descriptor. Like so, and then we will do all the loop over the clients, like so. I lower than the client's count, I plus plus, and then we will do all of this, but for the clients. And so the clients will start at index 1, so we should do I plus 1, like so. And this will be clients file descriptor I, and we also listen to poll in on those. That hasn't changed. And next we will just call the poll syscall, like so, with the file descriptor array we just created. We give it the size of it, so it's clients plus 1, which now I realize that that's not correct. It should be clients count plus 1. Yes. And we can give it a timeout. The timeout is in milliseconds, so let's just do 100 milliseconds. Let's assert that ret is different than -1. -1 is if there is an error. If ret is 0, I think Paul returns the number of file descriptor on which there was an event. So if there is none, that means that the timeout was hit, and we can just continue the loop. Otherwise, we can now check if pollFD is 0, so if the server r events is equal to pollin. So if there was something happening on the server, that means that a client wants to get accepted. So we will accept it, like so. And we will now say client's file descriptor a client count is equal to client FD. We'll add this client, and then we will increment the number of clients, like so, and we will just continue the loop. We can also assert that the client FD is different than -1. Why not? So that's the accepting new clients taken care of. So let's move on to reading from the existing client. So again, we're just gonna do a loop over the clients, like so, and we're gonna do the same condition. Like if there was any event for this client, so this client is I plus 1, yeah. If there was any event, that means we can read from it, receive from it. And so let's just put the whole receives thing in it, like so. And we can just replace this by client FD will become clients FD I, yeah. So, and so you can see that it's pretty much the same thing, but now, yeah, now we can receive from multiple clients. So let me show that I think this should work. Well, it's missing one thing, but I'll come to it after. So let's just run it. And now if we have our netcat here, it works, great. And if I have a second client here, it works as well. So both clients can now work in concurrently. So yeah, and that's pretty nice. There's one thing that's missing is that if I close a client, well, if I close a client, first of all, it didn't remove it for some reason, but oh, it did. But I think the removing is a bit sketchy because we don't actually remove them from the list. So I mean, let me just copy this from my example. But basically, all you need to do is remove the client that was closed from the file descriptor lists and decrement the client's counter. Of course, with this particular server, you can only handle a maximum of 1024 clients in parallel. But yeah, I hope that was a nice introduction to the poll thing. This can poll on any kind of file descriptor. So in this example, it was a TCP servers where you had the server file descriptor and the client file descriptors. But you could have this, but also files that you're currently reading and writing to. You can have a terminal if your if your application is very complex. Anything that can be represented with a file descriptor can be put in there. And yeah. So anyway, I hope you enjoyed the video, and I will see you in the next one.